Okay, welcome back. In this lesson or in this revision class, I'm going to be talking about hyperbolic functions of the form f of x equals to a over bx plus c. Hyperbolic functions of the form f of x equals to a over bx plus c. What does this mean? Now, obviously we talked about a various number of nonlinear functions. Mind you, this is still BS140 in case there can be somebody. So this is still BS140. So now, there are hyperbolic functions. There are different types of hyperbolic functions, different forms. But in BS140, which is business mathematics, we'll just be looking at hyperbolic functions of this nature or of this form, in the form of a over bx plus c. That is what we are looking at. So now, here we're just more concerned about how to graph them. So we are looking at the concept of how to graph these types of functions. How do you graph a hyperbolic function of this form? So what we need to know is this. What we just need to know is this. So graphing f of x equals to a over bx plus c is we use the reference graph, f of x equals to 1 over x. So this is a sketch. So now, what is the reference graph? So it means this is coming from this function. Maybe we can call this more like our parent function, and then everything will just lead to that hyperbolic part. So now, we are saying that if I was to sketch f of x equals to 1 over x, f of x equals to 1 over x has two types of asymptotes. When you sketch this graph, you're going to experience that this graph has two types of asymptotes. So remember, x is in the denominator. In short, when you see x being in the denominator, just know to say what you're going to see will be something in terms of hyperbolic form. So x in the denominator produces an hyperbolic graph. So x is in the denominator here. It means there is a restriction. Remember what we said last time. In the denominator, there should never be a 0. So it means when x is equals to 0, this whole function becomes what? Undefined. So that is why when you sketch f of x on the Cartesian plane, you are going to discover that the graph of f of x equals to 1 over x is going to be, if this is my y-axis and this is my x-axis, you are going to see that sketching this will just produce a graph which is going to be the curve this side and another curve this side. So this is a function of f of x equals to 1 over x with asymptotes of what? So you can see that these are just curves coming, getting attracted to the x-axis this side, and also maybe getting attracted to the y-axis and the y-axis there. So it means f of x equals to 1 over x has number one, you have to understand that it has a horizontal asymptote. Horizontal asymptote. Horizontal asymptote of y equal to 0. And it also has a vertical asymptote of x equal to 0. These are the two things you have to understand from y 1 over x function. So this line here, which is the x-axis, is the horizontal asymptote y equal to 0. And this line here, which is the y-axis, is the vertical asymptote, which is x equal to 0. So when the graph is sketched, the graph should not in any way cross or touch these lines. That's the behavior of 1 over x. So this is just a sketch. So when I'm sketching 1 over x, just sketching those two graphs and be able to say this is f of x equals to 1 over x. I've made my sketch. We don't care about certain things. The only thing we'll be interested in later on, if this graph undergoes a certain transformation and then maybe it crosses the x-axis or the y-axis somewhere, it means we have a duty to solve for that value of x or that value of y. But for now, the first important thing we have to understand is this is the graph of f of x equals to 1 over x. Next, now we are now looking at the function f of x equals to, so I will just try to write it in full, then we'll be able to break it down what everything means. So if I have f of x equals to a over bx plus c, and then I can have, let's say here, plus what? Let's say this is plus q. What you see here now, what does this tells you? When you're sketching your graph which is in this format, number one, understand that if a is positive, you experience a curve which is going to be like this. Remember, it's coming from 1 over x. So if this a here, which is here, is positive, you should be able to explain such a graph. Very important points you can just be able to take note of there. So these are the fastest way of sketching hyperbolic functions of that form. So just begin to start investigating. What is my a? Is a positive or negative? A is positive. Then it will be something of that nature. Next, if a is negative, then things have changed. Instead of graph facing in this direction, in these two quadrants, remember from the Cartesian plane we have about 4 quadrants. Quadrant 1, 2, 3, and 4. So it means if a is negative, the two hyperbolic curves will be facing the opposite of the first and the third. But if a is negative, you are going to experience the graph which is going to turn in the other opposite directions. These are, the other one will face in this direction, and the other one will face in that direction. That's the first trick you have to understand. So if a is positive, your graph should look like this. Your hyperbolic curve should look like that. If a is negative, your hyperbolic curve should look like that. And then we have q and this bx plus c. What does they tell us? So those tell us the asymptotes. So bx plus c, if I equate the denominator to be equal to 0, what I get will be the vertical asymptote or the y asymptote. So what I get if I equate bx plus c equal to 0, what I get will be the vertical asymptote. The vertical asymptote. So make x a subject. It means I'm going to have bx to be equals to c over b over b. And the value of x will be equals to c over b. Actually, this is negative, no code. This is negative c over b. So this becomes the vertical asymptote. Like a straight line passing at negative c over b. What is the q telling you? So the q is the horizontal asymptote. Horizontal what? Asymptote. That's the information you need to know. Once you know this, you should be able to sketch any hyperbolic function of that nature, of that form. So A tells you where your graph should be facing, in which quadrants. Bx plus c, the denominator, can help you come up with the vertical asymptote by equating it to 0. And this isolated guy, this value, tells you the horizontal asymptote. Let's look at a question. So the question is, graph the following. Graph the following functions. This is the, is it worksheet? The non-linear wave function worksheet 22. So graph the following function. So indicating, graph the following function indicating asymptotes and points of intersection. Points of intersection with the axis. With the axis. So what it means here is when you are sketching, the important thing, the asymptote and the point of intersection with the axis. The point of intersection with the axis means the intercepts. Where it's cutting the y-axis, when it is cutting the y-axis, you'll be able to tell and write the value. When it's cutting the x-axis, write the value. So graph the following functions indicating the asymptotes and points of intersection with the axis. Number 1, graph y equals to 20 over q. This is something where you don't even have to stress. When you're sketching this is your y-axis and this is your x-axis. There's a 0 there. We say that when it is positive, this is positive 20. So it means the graph is just going to be like that. And in this direction. And you're done. So this will be y equals to 20 over q without even thinking. That's your graph. Next, we look at when we have y to be equals to 4 over q minus 1. So what is happening here? Since we have q, it means q is the independent variable. So make sure you label your axis. So this is q and this is y. That's the important thing. And then we have y equals to 4 over q minus 1. This is positive 4, right? So if it is positive 4, what does that tell you? It means it is still in the opposite quadrant, quadrant 1 and quadrant 3. It's positive. This is the value of a. The value of a is positive, so it means it's in the diagonal, these quadrants. That's where your graph are going to be. Q minus 1 tells you to say that you can be able to come up with your what? Your asymptotes there. Now, in the first part here, the denominator is just q. It means the vertical asymptote, will be q equal to 0. This is why we have this line here, q equal to 0. This graph, when it is sketched, it is not going to touch or cross over this line. The horizontal asymptote, we say it is the value which is isolated here, but there is nothing here. It is just as good as saying plus 0. So if it is plus 0, it means the horizontal asymptote is y equal to 0. That's one thing we have to understand. That is why the graph is just has the vertical asymptote of 0 and the horizontal asymptote of 0 as well. But when we go to the second part, which says y is equals to 4 over q minus 1. 4 over q minus 1. What are you seeing? You are seeing that, number 1, there is a plus 0 here. That general form, the general form which you said it should be a over what? bx plus c in the denominator plus what? Q. But there is nothing here, it is plus 0. It means this plus 0 tells you the horizontal asymptote. The plus 0 which is here tells you the horizontal asymptote, which is y equal to 0. The denominator, bx plus c, is the one which was giving you the vertical asymptote. So here, the vertical asymptote will be when q minus 1 is equals to 0. And that will be q equals to what? Positive 1. This is the vertical asymptote. So when we sketch, what am I going to have? When I sketch, what am I going to have? If this is my y-axis and this is my x-axis, where we say this is q and this is y. We start our asymptote. Our asymptote, we have y equal to 0. It is still this same horizontal axis E. That q equal to 1 is a line passing through at 1 on the what? On the x-axis, on the quantity axis, since we are using the variable q. So it means my horizontal asymptote will be this one, passing through at what? At 1 there. So the asymptotes are the ones making the quadrant. So it means this time around, with this asymptote and this asymptote, I'm asking myself to say, where is the graph going to be? Is this in this direction or is that direction? So this is why we begin to what? To think and understand, to say what direction am I going to have the graph. So we can see that there is a shift in the asymptotes. You can delete some here. There's a shift in the asymptote. This asymptote here we have x equals to 1. It means by default there should be a graph which will cross the axis somewhere. So now we can see that A here is positive. So if A is positive, automatically I'm going to have a graph this side and another one this side. So remember, here it is going to cross the y-axis somewhere because the asymptote is at 1. It's going to just get attracted to the asymptote. So now the question is, at which point is this graph cutting this y-axis at? So this is the point, or maybe the value of y when x is what? 0, or when q is 0. So what is this point? So we're saying when q is equal to 0, we saw for y there. So y will be equals to 4 over q minus 1, and this will be equals to, after the q, put a 0. So this becomes 4 over 0 minus 1, and this becomes negative 4. It means at this particular point here where it's crossing, it's at negative 4. And you are done. Label your graph and begin to say, okay, this is y equals to 4 over q minus 1. You are done. So compare it with the general form a over bx plus c plus q. Whatever is isolated alone, this number which is isolated alone, is the horizontal asymptote. The denominator equal to 0 gives you the vertical asymptote. The value which is on the numerator here gives you the direction where your graph should be. If it is negative, it will be in the other sides. If it is positive, it is in these normal sides. Number 3. Number 3, we have sketching y equals to 5 plus 20 over q. What does this tells you? The denominator q tells you what the vertical asymptote. So we have a vertical asymptote of q equal to 0. The number isolated which is alone gives you the horizontal asymptote. The horizontal asymptote is y equals to what? 5. The value on top, this is positive 20. So it means this tells you the direction. It means obviously when I sketch my graph, I'm going to have this one and the other curve the other side. That's what you have to understand. If it was 5 minus 20 over q, it would have been this and this, since q 20 would have been negative. Now with this information, let's produce our graph. So what am I going to have? So we have, this is my y-axis and this is my quantity axis. So this is q and this is y. So vertical asymptote, q equal to 0, it is still this same straight line, y equal to 0, x equal to 0. This same y-axis is q equal to 0. Horizontal asymptote, y equal to 0, it should cross at 5 on y-axis. Maybe 5 is somewhere here. So that will be my horizontal asymptote here. This is my horizontal asymptote at 5. The vertical asymptote, it is still just this line passing through at what? At 0. So what am I being told? Now sketch. Positive 20, it means how is your graph going to be in these opposite directions? So I'm going to have one this side and the other one this side. So now what is happening? It has crossed the x-axis. So since it has crossed the x-axis, I have a duty to solve for what? The value of this q when y is what? 0. So we calculate when y is 0, what is what? What is q? So we're going to say that y, which was equals to 5 plus 20 over q, is 0 to be equals to 5 plus 20 over q. This can go to the other side, becomes negative 5 to be equals to 20 over q. And when we do the bad manners of cross multiplication, this will be negative 5q is equals to 20. And when we divide both sides by negative 5, the value of q becomes negative 4. So there need to be negative 4 there. And you are done. Don't forget to label your graph. This is y equals to 5 plus what? 20 over q. And you are done. So this is how you'll be able to solve and graph all your graphs in that question number 22 of your nonlinear function hyperbolic. So your exercise is the remaining. Can you go ahead and graph showing all the intercepts and also showing the intersection with the axis? So kindly graph number 1, y equals to 4 over q minus 1. Didn't I solve this one? And y equals to 4 over q plus 1. Kindly graph number 3. Number 3, y equals to 20 minus 4 over 4 plus q. Number 4, kindly graph y equals to 2 plus 1 over q plus 1. Yeah, guys, I think we'll meet again in the next lesson. You can submit to our inbox 0964 736805. Blessed day, morning and afternoon and evening.